So you guys are required to come to 10:20.
All right.
If you're not going to be material.
We can go ahead and get started. We finished last time without finishing up the problem. And we wanted to do this. We wanted to do this problem. It consisted of you have a wall or some suspension. You have a little hinge or a pin or something. We have a boom that's coming out from this wall, and on the end of this boom, we have a mass M. How long was this?
0.5
Yeah, 0.5 meters.
So this was 0.5 meters. From here to the mass. And then we also had a cable attached here and making a 45-degree angle with the wall. So this is the cable. And this cable has a braking spring. Cable breaks when the tension in the cable reaches more than 1,000 newtons. Right? This was 0.25 meters, right? Yeah. And the question was, we had two parts to this. One, what was the maximum hanging mass we could put here? What is max M? And the second part is 2. When I have this maximum mass and this tension, what is the force on the hinge or the pin? Force on pin. So this is the pin.
Is that also considered the pivot point?
Yeah, or pivot point, yeah. Pin, pivot point. In this case, when we have the maximum mass. So we did part 1 last time. Did we go through that again?
Yes, please.
Okay, we will go through that again. We were kind of rushed. And this boom we were treating, I mean, maybe it's like a carbon fiber boom. It's very lightweight. We're not going to worry about the mass on it, okay? The mass of the boom itself. All right, let's do 1. So first thing I do on these ones is I draw a free body diagram. And in this case, I'm going to draw it actually kind of as an extended free body diagram so that you draw the whole object. And then let's see if we can draw forces on this object, okay? So over here I have a force downwards from that mass. I know that that force is going to be mg downwards, okay? Then I have a tension force going off at an angle of 45 degrees upwards, because the tension force will go along the rope. And then I have some sort of force on the pin. Maybe I'll draw it downwards, but I'm not going to worry about it that much. Like that, okay? To figure out the max M, and this is usually the case with a situation like this. If I want to figure out either tension in the cable or the maximum mass I can hang off, what I'm going to do is I'm going to apply that sum of the torques is 0. Okay? So I'm going to look at the sum of the torques equals to 0. And that's good if I want to figure out any forces besides the force on the pivot point. The force on the pivot point, we gotta consider we gotta do something else. So first of all, let's look at the torque due to each of these forces. What's the torque due to this force?
Negative 0.5.
I'm just gonna label it with an mg. Yep. So how do you get it?
The R.
Yeah, so the R is
0.5
0.5 meters times mg.
And is it negative? 'Cause
And which direction did it make it want to rotate as we drew it?
clockwise.
So we're going to call that a negative. Okay? Make sense? All right. The torque due to the tension force is a little bit trickier. There's a couple ways you could do this. We can, of course, figure out an R perpendicular and then multiply by the tension force. Or we could take this as the R and look at the perpendicular component of the tension force. I think in my mind it's easier to look at the R and then look at the perpendicular component of the tension force. So if this is 45 degrees, this is also going to be 45 degrees, right? And then this would be that would be that would be the part of T that's perpendicular to the radius, this part. You see that?
Because of the 45 degrees.
Well, no, because this is R.
Mm-hmm.
This is the part of T that's perpendicular to that R. Right? Because there's a right angle there. And so I would put this as, and this is also going to be T, the magnitude of the tension force, and then this is the adjacent side of this 45 degrees. So I could write that as T cosine of 45 degrees. Right? So the R would be R, that's 0.25 meters, times T cosine 45 degrees.
Why did we do sine of 45 degrees last time?
Oh, that one, I wrote the perpendicular component like that.
Oh, okay.
It'll be the same
Oh,
thing.
okay.
Yeah. Just two ways of looking at it. Anyway, so, and I'm interested in solving for this M, for this part one, and what do I know about this T if I'm interested in? Well, what would that be?
1,000 newtons.
Yeah, we're interested in the M when this is at its maximum value, just getting ready to break. And so I plug in 1,000 newtons for the tension. So I'd get 0.25 meters times 1,000 newtons times cosine of 45 degrees, which is 1 over square root of 2. And what would you get for this?
$176.
Okay.
Maybe Newton meters, is it?
Yeah. Good. All right. Now, what do we know about the sum of these torques?
That-
It's going to be zero,
Zero,
right?
but then-
Is there any torque due to this? No, because the R perpendicular to this pivot point, 0. So this force on the pivot point doesn't cause any torque. So that means that I'm just going to add this to this and solve for M. So I'm going to do that over here. So I get 176 Newton meters minus 0.5 meters times G times M is equal to 0. I can add this to both sides of the equation and get 176 Newton meters is equal to 0.5 meters times G times M. And then I can solve for the mass. Meters times G is equal to M. And I'm kind of working with numbers. Remember, it's not really a good idea to work with numbers till the last step, but I'm doing it anyways. It is what it is. I should be okay. This would be 9.8 meters per second squared. What would I get?
36.1.
kilograms. All right, very good. Everyone understand that? So I just summed up the torques, set the result equal to 0. Okay. Now there's two parts to being in equilibrium. What's the other part?
The sum of the forces are also equal.
Yeah, that's right. So in order to do 2, we know now what this mass is, we know what the tension force is at its maximum value. So I know this force and I know this force. If I want to get this force, I gotta solve for it. But here's what I know. I know that in equilibrium, sum of the forces is equal to 0 because acceleration is 0. And so I can do the force on the pivot plus that tension force plus that force downwards on it, and G is equal to 0. So this is a vector equation. I got to write these as in terms of components if I want to figure out what that is. Okay, so force pivot is equal to minus the tension force minus mg downwards. Solving for that, right? What is this? Let's break this up into components. Mg vector is minus mg y hat if I'm introducing my normal coordinate system of x and y. Okay, because it points downwards. So that means minus mg is just mg y hat. Okay. Tension force. Tension force is 1,000, the magnitude of it's 1,000 newtons, and it points off at that angle. So if I want to split it up into x and y components, this component would be 1,000 newtons cosine of 45 degrees in the negative x hat direction, right? And this one would be 1,000 newtons.
Positive y.
Yeah, that's right.
Oh, and cosine.
Cosine.
Sine.
Yeah. So it'd be 1,000 newtons. By the way, well, it would be the same thing. Cosine of 45 degrees. X hat, minus sign here. Plus 1,000 newtons. Sine of 45 degrees, y hat. You see what I did here, there? Splitting them up into components, x and y components. All right. What is that?
Is it negative 1,000?
Yeah, negative 1,000 cosine of 45 degrees x hat because it points in the negative direction.
Do you want just the x component?
Yeah, it'll be the
they
same.
won't.
It'll be the same.
So negative 707.
Alright, so that's negative 707 newtons x hat plus 707 newtons y hat. Okay, so negative t would be the negative of that. And that mg, that was 36.1 kilograms. So what would this negative mg be?
Just the mass.
Yeah, 36.1 kilograms and 9.8 meters per second squared. And what is that?
Negative 353.8.
Negative 350 plus 254 newtons. Why that?
So you took the components and plugged it back into that equation.
Yeah, well, now I know negative t, I know what negative mg is, I can just write out what the force of the pivot is. So what is the force on the pivot? Erase this. So I'll just add this vector and I'll add this vector. So I'll get 707 newtons x hat. And then what do I get in the y hat direction?
Minus 353 newtons.
It's minus 353 newtons y hat. Okay? So if I were to draw that out, it goes downwards into the, looks like kind of like that, right?
Just around between the two curves.
Yeah.
There, 54 there.
No, this one, I added this to this, right? Negative 707 newtons y hat plus 354 newtons y hat, and so you'll get negative 353. Okay? That make sense to you guys? Or, I don't know if I've lost everyone.
Where does the equation over here, the mg equals negative mgy, coming from the last equation, how did we get to that?
This?
Yes.
Okay, let's look at that mg vector. Has a magnitude mg, points in the negative y direction. Okay? So that's it.
Okay.
All right, you want to do another one on your own? I'll give you a little simpler one. You're going to have to do this on your own at some point.
Can we do another example first?
Just out of curiosity,
Yeah.
we've got what they put in our table on that page along that.
No, we're not treating that as a pivot.
Because that point is coming down.
What's that? This point's fixed. This point's not fixed.
Because it's negative mg. So is it
That's how I see it.
All right, we can do one more. I think what we'll do we have some groups? Why don't you guys split up into groups of 3, okay? So go ahead and get 3 people together. So Samantha, you 2 people in your row. Next, or next.
What?
You guys, yeah, 3. Why don't we split up into about groups of 3? I wish we had this. Oh, actually, I guess we can do this. I'll be right back. 1 second.
I should have canceled. I should have I feel like at least
I know you said about that YouTube video. Yeah. See, the way you looked at that, like, it's like, it looked like you were saying, "Are you serious?" But really, you're like, easy. You just have a lot of
not exactly sure how it got switched in.
All right. So, one person from every group come up, grab one of these, okay?
No joke.
Are you with them? Are you
on the bed. I'm not coming. Are you in bed still?
By the way, when did I say the homework was due?
Next
Wednesday.
Okay, good. I was getting really worried. Okay, everyone, every group got their whiteboard? Do you have enough whiteboards? Well, I can go get another one.
Jacob's second chance to raise This isn't even raised, man. This is confirmed.
I think you're just unmuting it because you feel called.
Okay,
Fair enough. I would give it once.
so here's what we're gonna do. Here's a problem. We have a boom. Let me give you some examples. This boom is 2 meters long. This is 1 meter to the center, and then this is 0.3 meters over the side, 30 centimeters to the side. This boom is suspended at this point on the wall. Okay?
So the boom's weight itself is longer.
Yeah.
Okay.
Now, here's the rule that we're gonna do. Here's what we're gonna do. I want you guys to figure out the tension here. The tension's pointing straight up, and there's a rope straight up holding up the boom. I'm gonna give you guys a 2-minute head start to figure out what that tension is, and then I'm gonna race you. Okay? So as your group, you better work fast. All right, I'll give you a 2-minute head start.
Go in the other room. Don't look at it.
That's okay. I'm gonna ignore those.
So first let's draw three body diagrams. Yeah, so you're on lifting, there's an MC going down, and then the mass also detention yeah, so this is MG, right? Yeah, and so
Can you toss us a
once you do that, 1,000 times 1.8. And then here, this is 100 times 9.8. Oh, yeah.
The tension is going to be the sum of all forces in
When your group is done, just raise your hand, okay?
Oh, yeah. And then, so the torque, you have to do the torque. No, it's not like
What it just do?
night. So this works, one would be, what is the whole thing? It's
2 meters is the whole thing.
Times,
Clockwise.
like that. And then this one, oh, would it be negative? Yeah, because,
Yes, it would be going clockwise.
and then this one will be, what is that, 0.3? Or is it 1 meter, 1 meter? One
yeah, that
times,
one.
1 meter times,
100.
90.
Or the 90. 900.
Okay. And then what are we doing?
Tension, we're trying to find the
Oh,
And so the tension force is going to be it's going to be the opposite, but we have the distance, so we break it down into its components.
Oh.
And then you make it equal to that because it's the opposite of that.
so there's, this is the, like, this is the thing, 0.3. So, like,
Times 10.
this is the perpendicular force, so this is,
So the torque is going to be 0.3 times T. That's the torque. And then you set these torques equal to that one, I'm pretty sure, because it's the
you add them all.
Because those are both masses.
Yeah, you do.
because it cancels out, I think, right?
What?
If it's staying still, it cancels out, so yeah, you would add them all, I think.
I think you add them.
Yeah.
0.3 plus, oh, do we need to make sure this is this one in the negative direction also?
Yeah, it'd be in the negative direction also.
This one is the
Yeah.
No, well, you said you add them first and then you when that's when you subtract them.
So yeah, you first have to.
I say
she's
let's
right.
add them first. Because
She's
I
right,
wanna-
because if we skip it, so that we mess it
Yeah,
up.
and so this is also negative, so minus 90.
Then you divide that meters back.
Because it's 1, right? And then is this gonna be in the positive direction?
The torque?
Yeah.
Yeah, because it's going clockwise, so, or I mean counterclockwise.
So that would be, no, that's positive. The other one's negative.
Tension force, minus 71.
Which one? Sorry.
Because these two are negative. So what's 2 times 90? Yeah. 19,000.
What is it? Oh, because the range. Or,
Newton meters. I don't want to see. Okay, and then now we, that's like basically like you said.
no, for sure, it was a smart move.
So now we divide this. So divide this by.
Why is this positive?
I don't know if we're right, but. Yeah.
Okay.
So it's 90.
Wait, that's 1,000 kilograms, that's got it. That's huge.
Is that a huge tension force?
That's what you got, right?
That's just for you.
So it's
Go with that.
68,600.
Yeah, they're both mass and variation. They will actually.
Do we tell you when we're done?
I didn't realize what variation is. 1100 kilograms.
We're done.
Oh, you done? Okay, turn it over.
That's what I got.
Added because we added them.
Oh, you added this, okay. I got you.
And that's a 0, right?
Yeah, that's 0.
Yeah, 6 years in.
We don't know. We're done.
Were we supposed to show?
Yeah, show your work.
Who thinks we're done?
I don't know.
And you guys are not done yet because you didn't write it.
Tension force doesn't originate in the
You did it in your head?
I try it.
Yeah, he did.
Okay.
Previous problem, tension right in the middle.
All right, you guys ready? Let's go through this one. If you haven't done it already, you're too slow. All right, why don't you show us what you did? Okay, you got my answer.
Yes. Awesome.
Let's flip it around.
Oh no, it's my.
Now, don't worry about the handwriting, it's better than mine. So, what do you guys do?
So we first drew the body diagram, free body diagram right there, and put the forces there, and then we added all the torques. First, we figured out the torques because there are times the force, and then once we have that, we added them all to, and then solved for the tension force.
All right, so you got 68,600. Who else got that number? You guys got it? You guys? Anyone over here? Okay, that's what I got. Let me go through it real quick, okay? That's good. So what I did was following, I did the free body diagram. I'll do it a little bit neater, okay, so you can see. So I had tension going up like this. I called this M1G down at the center, and I called this M2G coming down on the side. Okay? This was, well, here's what I did. I called this R. I called this 2R, because it's twice as far, right? And I called this 0.3R. Okay? Then I summed up the torques due to each of these forces. The sum of the torque is, so this force here has a torque that's causing it to rotate clockwise, right?
Yeah.
So the torque would be minus 2Rm2G. See? You see why that would be the case? This perpendicular distance 2R, M2G is the force downwards, minus sign. This torque here was minus R M1G. And then this torque here was plus magnitude of the tension force times 0.3R, and that's equal to 0. Right? Now I can divide through by all the R's. And then if I'm trying to solve for the tension, so I'll bring all these over to this side. And so I'll have tension times 0.3 is equal to 2 M2G plus M1G, which is 2 M2 plus M1 times G. You see what I did there? And then I divided by 0.3. So tension is equal to 2 M2 plus M1 times G over 0.3. And so that would be equal to 2,000. This is 2,000 kilograms. This is 100 kilograms. So 2,100 kilograms times 9.8 divided by 0.3. And when I evaluated it, I got 68,600 newtons. Okay? All right. Let's do another one. This time, let's switch up the groups a little bit. Up here seems to be a slow set of people, not to be mean. So, I don't mean slow, I just mean that the problem was slow. Okay. So, Salam, switch, can you switch with Christy up there? Marissa, could you switch with Marshall? Marshall? Brandon? Could you switch with Rick over here? And Colton? Could you switch with Zane over here? Okay? Wait. One other.
Do you have the eraser?
All right. got these things. Believe me, those were racing rags.
Did he say your sister's
That's right.
rag?
And Izzy,
Yeah.
can you switch with the, who else? Maybe Wanda over here, let's see.
Okay.
I don't know. How to, we'll switch it around. Okay. So next problem. Might as well do these torque ones until we're fast at them. Okay. Okay, these torque problems they're kind of fun, I guess. So, this is 100 kilograms again, and let's say that this whole thing is 1 meter, and that this center of mass where the gravity acts is halfway along here. Okay. Let's say that I'm hanging up a huge mass here that's about 2,000 kilograms, that's 2 tons, 2 metric tons. And I have a rope going down here. This distance is 0.3 meters. This distance is 0.7 meters. Okay? And this thing is being held up, and we'll do it simply so there's no angle. This thing's being held up once again by a tension force going upwards. And then this thing will be 0.2 meters. Okay. So I'm going to give you a 4-minute head start. 4 minutes. And then I'll race you guys. See if you can figure out this tension for us.
That's 0.2? Is that what you said?
This distance is 0.2 to the tension force. This distance is 0.3 to this first thing. And then this distance to the second thing is 0.7.
So how is the whole thing 1 meter then?
And then this room is 1 meter.
There you go.
Because 0.7 is from the wall.
Oh, I see. Okay.
Okay, so let's just do it exactly how we did the last one, but with that caveat.
I know you guys are shy, but it's okay to work together.
Okay, so we're starting towards,
The tension of
this one is halfway in between, so it's 0.5.
the tension of the boom, just the boom,
Are you guys done?
is
Okay, so
0.5 is the distance of the boom, and then that's multiplied by 100. Yes.
So this is a little hanging metal,
100 kilograms.
you know, and then so there's.
Okay, tension of the first weight tension of the is going to be, the distance is 0.3. Probably.
Yeah, this one, but it's got 2 ropes, so I guess we'll
So
just
yeah,
split the weight in half.
And then the other one is
Plus it was like the point group. It's supposed to be like.
I'm curious.
So you're pointing one of mine.
We only have 3 years. 100 kilograms, so we just have 1, 2,
So then you ask one person.
yeah.
You got 2.
We're getting a head start.
I'm not even, I have to
Okay, so then we have to set them all equal to 0. Set them all equal to 0.
Are you dividing the mass in
So
half?
you have to add in all the tension.
So what I did.
So that's going to be R times T. So, I don't know. Doesn't have to be because you're
Well,
if you need somebody kind of
Okay, tell me the numbers.
2,500 kilograms.
just with
What? Hold on, what?
25.
25 times a point. Okay.
So I actually
That's gonna be 400, wait, 490. 490. Okay. The next one is what? It's gonna be, yeah, 29.
I'm gonna translate it across.
So we add all those up
yeah.
and then divide by what?
'Cause it gets me to be under 10,000.
What did you get through that? You did them together.
Oh, instead of.
All right, put it over first. We'll check it, okay? So, we'll check their one, but they look like they're first.
Just wait, that's not.
All right, I'm gonna get started. You have time to check, by the way.
Because it equals.
And it'll be
Sorry, 51,000. Those are the
R,
dollars.
the R, the mass,
The weight math. Well,
the boom, and then
that's the other thing I do.
and then the R.
And because it's being hoisted up, it's all equal to 0. Oh, we forgot direction.
Those are all.
Those are all going to be negative.
That's why.
So that's why it's positive.
Yeah. Because like how do
Nice.
Sorry.
they'd all be added to
You got like
T equals 0. So yeah, I mean, I like
Does that make sense to you? Yeah. That was that what you got? Yep.
yeah, we'll just.
Would think like I.
It might be.
that's the
Whatever.
That's still going on.
is that 0.3?
But it makes sense.
That's what the holding the mass. Oh, gotcha. Yeah.
Well, this one would be the big
Yeah, that's why I put like 1/2 and then yeah. Like
Gotcha.
Maybe you still divided by 2.
How did you get the torques in your head so fast? How did you do that? You did that all in your head. How did you do that?
do what, Mike?
So because
Did you do the torques in your head, or did you do those? Like,
You times it all.
yeah, you got to.
I typed out divided by.
No, yeah, she.
Oh, you typed it.
Yeah, she was freaking out. I was like,
No, when you started that one, I just started from the bottom and went up.
freaking out. Time to
Doing this.
I was like, oh, my head.
I was like, there's no I guess they're actually you just because if you were just to assume that this is 10, then all you do is you multiply this.
Oh, is yours different?
Yeah, a little bit.
Yeah.
Just a little bit. So that's
I don't think we are.
Okay, I'm ready now. I got it.
What's the answer?
Okay, so who has it done already? Who beat me? Wow, all groups. Okay, so a lot of groups. Okay, what do you guys get back there?
We got 17,100.
Okay, that's not what I got. What do you guys get?
Right here?
We got. Okay, so 53,900. I got 51,450. Oh, wow, okay. In the back, did you finish it? What do you get?
51,450.
Okay, and you guys didn't get it done.
Oh, we did, but it's not right, so we may not right.
Okay. All right, let's go through it real quick. Now, this is the tricky one right here. This is the part that's confusing.
Yeah.
All right, so if I were to look at this thing, 2,000 thing here, I have an mg downward, and then two forces going upwards. If you had different forces here, this thing would be tilted, right?
Yes.
So that means that this total weight force has to be divided evenly, you know, provided that these are right at the edge, between these two ropes. Okay, that's probably that's like a key step here. All right, so what I'm going to do is I'm going to call this M2. I'm going to call this M1. What I did was, okay, I said this is the sum of the torques on this boom. I have a force down here, a force down here, force down here at 0.3 meters, 0.5 meters, and then this one was 0.7 meters. And then I have a force upwards at 0.2 meters. And then this was M2 over 2G, M2 over 2G. You see why I did that way? Half the weight of that M2 is being supported in each of these positions. And this I just called M1G downwards. So these three torques are wanting to make it rotate counterclockwise. This torque makes it want to rotate, no. These three torques make it want to rotate clockwise. This torque makes it want to rotate counterclockwise. And I'm going to call this the tension. So if I want this to be in equilibrium, I'm going to skip a step. I'm going to say, okay, the torques due to these forces are negative. Torques due to this force is positive. They have to add up to 0. So that means the sum of these torques, the absolute value of it, plus is equal to this torque. Does that make sense? So I can say that tension times 0.2 meters is going to be equal to M2 over 2G times 0.3 meters plus M1G times 0.5 meters plus M2 over 2G times 0.7 meters. This is 1,000 here, 100, 1,000. When I do all this, I got something like 17, I don't remember exactly what it was, 10,000 or something like that.
10,290.
Yeah, and then I divide by 0.2. So I get tension is equal to whatever this was.
10,290.
90 meters. And meters divided by 0.2 newtons, and that was 51,400 newtons.
Why is it Newton?
Force.
Oh, because
Well,
the time
because
is
this
never
is a
mind.
force I'm finding, right? And so.
No,
I took-
I'm saying the 0.2 in the bottom.
Oh, yeah, that's meters.
Meters.
Yeah. Very good. That makes sense to everyone? All right, well, unfortunately, I don't have any more time. kind of helps to rush through problems if you don't, for some reason, you can see whether you're able to do that.
That's perfect. What I did, when I went to subtract, I only switched the first one. I left these